Okay, yesterday I wasn't able to take the class, so today we'll continue. So today is day 15. We'll cover machine learning. So previously we covered day 1 to day 3 statistics and probability, and from day 4 to day 14 we covered Python. Okay, and then now we are going to start machine learning. Okay, introduction to machine learning we'll see, and types of machine learning, data preparation, data cleaning, handling categorical variables, test train split, and standard scalar. These topics we'll cover today. Okay, so all the previous videos you will find in our YouTube channel. So this is our bigdatahands.com website. This is our website. Okay, you can visit our website. If you have any queries, any doubts, you can message us in this number 978 or you can send an email through support@bigdatahandson.com. So all the videos you can find it in our YouTube channel bigdatahandson.com. If you subscribe to our channel, you will get all the updates. Okay, these are all the videos previously taken, Python videos and statistics and probability. So let's start today's session. So those who are new today, we are going to use a different environment. That means a new environment for machine learning only. That is Anaconda. If you don't have installed in your system, you can install it in from you can say you can type in Google Anaconda Python, and you can see the individual edition here. From there you can install the Anaconda software. I will show you alternative ways also. So you can press the download button here, and you can see for Windows, Mac, Linux, the distributions we have. Okay, so those who are not interested in installing these softwares in your machine, okay, don't worry, we have another alternative option. If you have a Google account, that's enough. So let's go to your drive, and from this you can create a notebook called collaboratory notebook. So this is developed by Google. Okay, this is a free of cost. You can use if you have a Google Drive. Okay, and press the new button, and here in the more option you will see Google Collaboratory. If you don't see, you can connect it from connect more apps, and you can search in here in the search bar. You will find the Collaboratory and install it. Okay, you can search here. Okay, after installing that you will find in the more option here. Okay, if you press the Google Collaboratory but option, you will be uh, create a notebook, a new notebook. There you will start coding. Okay, without any installation. Now let's move on to the slides. Start from so so we are going to start machine learning today, right? So what is machine learning? So machine learning is a subset of AI. So why we need machine learning is because machine learning is nothing but a process which the system improves the performance from the experience, past experience, we can say. Humans also that's the same, because we learn from the past experience. Okay, so we improve. For example, uh, an action you are doing, that action can be a positive or negative, or you can say you can give you a reward, or you can get a punishment. So based on that you will improve your performance. Okay, that's not correct action, we need to do with a different action. So like that we'll improve our performance by the past experience. So here in machine learning we improve the system based on the past experience. Here past experience is nothing but data, you can say. Okay, so the data is the past experience for the system. We provide the data, and the machine learning algorithms will learn from the data and improves the performance. And after that you can predict the future. Okay, in future what will happen if the data is like this, what will be the result. Okay, so that's the concept of machine learning actually. Okay, so the definition is learning is any process by which a system improves performance from experience. Okay, a computer program is said to learn from experience with respect to some class of task T and performance measure P. If its performance as task T as measured by P improves with experience E. Okay, so now when would we use machine learning? So machine learning we use when human expertise does not exist, navigation on Mars, and speech recognition, or in medical field also. Like if you want to check whether the medicine, a drug can be helpful to cure the uh, okay, models must be customized, personalized medicines. Okay, if you want to predict the medicine, and models are based on huge amounts of data. So it's like when you have huge amount of data, our result will be a good one actually. In medical fields also we use machine learning to predict whether the person, for example, whether the person has cancer or not. For this person, if I give this medicine, it will cure or not. So like that we can predict actually, we can create a models for that. Okay, so in medical field if you are doing that, model should be an accurate one. Okay. Okay, types of machine learning. So machine learning has three types of in subset in machine learning we have three subsets, that is supervised learning, unsupervised learning, reinforcement learning. And the machine learning, the learning are separated into three parts: supervised, unsupervised, reinforcement. So we'll see one by one. So supervised learning is like a student teacher. For example, teacher teaches the student, and the student will learn what the teacher is teaching them. Okay, and then they can solve some mathematical problems. Let's say the teacher is teaching the students, for example, 2 plus 2 equal to 4 and 3 plus 3 equal to 6, like that. And then the teacher will ask some questions, the students should answer the questions, so based on what the teacher teaches. Okay, so that means the supervised learning is task driven. That means we give the labeled data. For example, if this data comes, this will be the output, this data comes, this will be the output, like that we'll give as a labeled data. So after that he can if the new data comes, uh, the supervised learning can predict the outcome. So okay, and then unsupervised learning. Unsupervised learning, we don't have any supervision like teacher. Okay, so it needs to learn itself, like self learning. We need to learn a self uh, learning process is unsupervised learning. It's a data driven. That means if you have a data, will this unsupervised learning will try to figure out the relationship between the data by clustering the data. It will create some clusters, and based on the clusters will tell us what the data is about. Okay, so that's the unsupervised learning. So in unsupervised learning we don't have any labeled data like in supervised learning. Okay, it's an unlabeled data actually. let's come to reinforcement learning. So reinforcement learning is a process of we can say trial and error, or if you're doing an action in the environment, he will get a reward or a punishment. So based on that, he will improve the action. So algorithms learns to react to an environment. Okay, this is the type of reinforcement learning. Okay, so let's see first in supervised learning. In supervised learning, here you can see in supervised learning also we have two types: regression and classification. So what is regression and classification? So we can say uh, regression is for a continuous type of data, classification is for a categorical type of data. Okay, that means the outcome is, when the outcome is categorical, you need to go for the classification algorithms. In supervised learning, the major two parts is classification and regression. In that classification we will have many algorithms, for regression we will have many algorithms. So first we need to choose whether that is regression or classification. So we can choose this regression or classification based on the outcome. If the outcome is like a categorical one, you can choose classification. If that is a continuous type of data, you can choose regression, like an income in function of age, weight of the fruit in function of its length. So it's continuous, right? So if that outcome is continuous, you can choose regression models. If the outcome is classifiable, like categorical type of data, okay, one or two or more like that, okay, then you can choose classification algorithms. Okay, let's see unsupervised learning. So we know that unsupervised learning is not a super, it don't have any supervision. It learns self learning. So here is the data. So what the unsupervised learning algorithms will do is, it will create some clusters of this data. So you can see we have two clusters here. So the unsupervised learning will separate these two clusters. So okay, so the methods we have is k-means, Gaussian mixer. These are some algorithms of unsupervised learning: k-means clustering, hierarchical clustering, Gaussian mixture, spectral clustering. Okay, these are the algorithms we can say in unsupervised learning. Okay, and then the reinforcement learning. So reinforcement learning, already we know that we have an agent. Okay, this agent reacts let's say takes an action on this environment. Okay, we have the environment also. The agent takes an action on the environment. That action uh, will give for him a reward, or it can give a punishment. So this will do, the interpreter will do a reward or a punishment it will give, and then the state will be updated. Okay, so this was the process of reinforcement learning. We'll see the reinforcement learning in the last one. Last 8 sessions are for reinforcement learning. Okay, we'll see many algorithms on the reinforcement learning. Okay, now and then we have machine learning tools. So we can do machine learning in other languages also, like Java or Scala or .NET, C++. We have other languages also. Why we are using Python is because the Python is very useful. Sorry, it is uh, easy to learn. So a simple lines of code, 4 lines of code may be enough for this. So for this Python, we have a tool, or you can say a library, scikit-learn. Okay, for different languages we have different libraries, like C++ we have mlpack, Scala, mllib, Java, rapid miner. So like that in Python we have a library, scikit-learn. So using the scikit-learn, we can create a machine learning model using the scikit-learn library. Okay, so this scikit-learn library, you need to, if you have a Python installed already, you can, one way is you can install the library via like pip install scikit-learn, or else you can use a software that provides all the libraries for machine learning that I have already shown you. Anaconda. Okay, you can install using this, and then you can start type coding on any IDE which Anaconda provides, like Spider, Jupyter Lab, Jupyter Notebook. uh, so you can type uh, on the IDEs. Okay, or else if you don't want to install any software, I said before, we can use a notebook, collaboratory notebook. So you can, if you click the Google Collaboratory, it will take you to the notebook. It will create a notebook. All the notebook will be stored in your drive only. Okay, it will store in the drive. So here we have created a new notebook, and after creating the new notebook, you want to connect to the environment. Here is the connect button. It will connect to the environment. After connected, you can start type coding. So I said we are going to use a tool for machine learning in Python, that is scikit-learn. Let's check whether this environment has that library or not. Like you can say sklearn, that is scikit-learn. Okay, sklearn. If you say import sklearn, if it executes without error, that means we have already installed the sklearn. So this environment has this library sklearn. So you can type the you can start type the coding. Okay, now I'm going to use not this notebook. I'm going to use an IDE from Anaconda. Let me open Anaconda Navigator. So I'm going to use Spider IDE. So, and then we have the next slide will be the steps of machine learning. So we need to follow these 5 steps. One is get data. If you want to create a machine learning model, that means of course you want the data to create your model. Okay, and then we'll clean, prepare, transform the data, and manipulate the data, visualize the data, what the data is about. Okay, so we'll do that in the next step, second step. And in the third step, what we'll do, we'll train the model using the prepared data what we have. And then it will give you the data, and then based on the given data it will create a model, and we'll test the model in a new data. Okay, so usually we train the model and test the model in a different data. That means let's say you are teaching the student 2 plus 2 equal to 4. We'll give a new data for them, 3 plus 5. What is the result? We'll ask. We don't ask what is the 2 plus 2 result. And then the student, of course, will tell the correct answer because we have already. Uh, wait. Okay. So that's the fourth step. We usually test our model. If that, what is the performance of our model? Then in the first and then the fifth step, we'll improve the performance of our model. Okay, by some tuning parameters like that. Okay, so Anaconda Navigator is opened. Here you can see many tools here installed. So like Jupyter Lab, Jupyter Notebook, Qt Console. So we are using going to use Spider, so we can launch from here. You can use Visual Studio Code also if you have the environment. Like Anaconda Navigator uses an environment called Conda. So inside the Conda, it has its own Python installed. So what you can do is, in the Visual Studio Code, you can select the environment. Okay, it will show you the Anaconda's environment. If you select the environment, you can type in Visual Studio Code also, because in the environment only we have all the libraries installed, like scikit-learn for machine learning, or you can say keras, tensorflow. These are all the libraries we will use. Actually, keras and tensorflow are not installed in Anaconda Navigator. That library we need to install manually actually. Okay, now this is the spider IDE. First let me create a new file. It's taking long. Okay, so now we'll create a new file. Click on the file button, new file, and then we can remove this content inside and then save this file. I, let's name as pre-processing. So today we are not going to create any models. We're just going to prepare the data for creating the model. From today we'll start one by one algorithms. Okay, so because we have many algorithms in machine learning, we see one by one in day wise. Okay, so first what we need to do is, let's take a data. For example, here in the data set we have data. So let's take this data, a simple data. So this data we are going to prepare for going to clean the data. We are going to you can see here we have some categorical type of data. We need to convert the categorical into numerical ones. So all these things can be done using the libraries called pandas and numpy. These are libraries which we use for data handle the data. To handle the data we use pandas and numpy. If you want to visualize the data, we have a library called matplotlib, or you can say cbon. In libraries you can use matplotlib. So in this library we want to import first. Okay, so let's run this. So again, you don't have to install any libraries. All the libraries are available in the Anaconda environment. So we have imported the libraries. Now what, we are going to read the data from this file. data.csv, right? So using pandas, what you can do is create a variable called data. Okay, and then here in the pandas library we have a function called read csv. If you want to read from csv file, you can use read csv file, read csv function. Or if you want to read from excel or other files types, so you can provide here read underscore csv, and then you need to give the uh, path of the file. Okay, so you can give whole path, or you can say simply dataset slash data.csv. You can give like that also, because the file is saved in that directory only, this file, this preprocessing.py, right? And now, so you need to provide that path in the double quotes or single quote. Okay, datasets slash data.csv. Okay, so now if you run this program, it will read the data and create a data frame, a pandas data frame. You can visualize here in the variable explorer. If we go in the tab variable explorer, you will see the data here. If you double click on the data, you will get a like this. You can visualize like this. This is the table. So this has 4 columns, right? Country, age, salary, purchased. So country column contains like France, Spain, Germany. So these are the country names. Okay, and age we have, salary we have, purchased or not, if that person, if that customer purchased this product or not. Okay, that's what it is. And here if you see in the age column, we have a nan, and the salary we have a nan. So nan is nothing but an empty cell. Okay, that means here we don't have any data, so we need to fill that. Why is because if you give without filling this nan values, our model will not work properly, because it will crash. The nan value is empty value, right? If you multiply with some values, it will give you error. So that's why we need to handle these missing values. First step is that one. We need to handle the missing value to prepare this data set, right? And then the next step will be here. If you see in the country, France, Spain, Germany we have, in purchase no s like that we have. These are the categorical type of data. Okay, in the second step what we'll do, we'll convert this categorical type of data into a numerical one. So again, all the machine learning and AI algorithms are built up with mathematical equations, right? So we cannot simply multiply no to some other values, right? So that's why we need to convert this uh, categorical type of data into a numerical one. Okay, and that's the second step. And the third step will be uh, splitting the data set into training and testing. What does that mean? So splitting the data set into training and splitting is because if you see in this slide, you will see we have two steps, right? Training the model, testing the model. But we have provide only one data, this data only. Okay, so to use for training and testing, we split the data set into training and testing. This data set will be split into two parts. Okay, so one part we'll use for training and one part we'll use for testing. So we need to use a different data for both, like training for different data, testing for different data. So why is because that the same example I told you na. So if you're teaching 2 plus 2, again if you ask the student 2 plus 2, it will give you, he will give you correct answer 4. But if you want to tell, if you want to test the performance of the student, you need to give a different uh, uh, problems, right? So that's why we use a different type of data for training and testing. Okay, the third step will be splitting the data set, and the fourth step would be we'll scale the data set. What is scaling, right? We'll see that later. Okay, scaling part will do. Okay, so let's start from filling the nan values, filling the empty values. Okay, so before that, let's see some useful functions in the data frame, pandas data frame. Like info, we have, if you say info, it will give what are the columns we have, and and what are the type of the data provided in this column. Okay, so you can, let's say if you have a huge data, how can I know that this many values are missing? If you have like this data, you can easily count, right? So age column has an empty value, like salary column has an empty value. If you have a huge amount of data, how can you count how many nan values are there? So a useful method is you can do like this: data dot is null, sorry, is na, right? Is na dot sum. So using this you can uh, count how many nan values are there. So country column has 0 nan values, age column has 1 nan value, salary column has 1 nan value, purchased column has 0 nan values. Okay, so using this you can find. And another way, another function useful is data dot describe function. Describe function will give you on the numerical data, on the numerical columns only. Okay, how many count, how many values are there, what's the mean of the column, and what's the standard deviation, and the minimum value, maximum value. These are some interquartile ranges, like 50th percentile, 25th percentile, 75th percentile. So it will give you all the details of the data. Okay, so how can I fill the mean value? Sorry, nan value. To fill the nan value, we have some methods. Like we can fill the nan values by 0, that's your wish. You can fill the 0 values, or you can drop the column also. If you have more than 1% of data is nan, then don't remove the columns because it will be a data loss. Okay, loss of data. So what we can do is we can fill the values with some other values. Like we can fill with 0, or we can fill with mean or median. Like we can fill that. Okay, okay, so to do that, uh, we can have two ways of doing, like filling the nan values. One is we can fill the nan values by using the pandas libraries, or we can fill the nan values using the scikit-learn. Okay, this tool for machine learning, right? So we have two ways. Let's see using pandas how can we do that. So let's take the values, what are the values we are going to fill. So these two columns only has the empty values, age and salary. Let's say I'm going to fill the nan values of age column by its mean, and the salary column by its mean. Okay, so if you want to provide it in a dictionary, like in the dictionary we'll have the column name, age, and for that column what value I'm going to fill. I'm going to fill the mean of the this column, mean of this age column. How can I find the mean of this age column? Simply you can say data of age, the column name, and then dot mean. Dot mean, if you put, it will give you the mean value of this column. This is the mean value. So take this line and put in this after the column. So for each column we'll fill this value 38.778. And the same as for salary column, salary. Okay, so we have the uh, values, right? Now this value we need to fill for the NaN values. How can we do that? So using the data frame, data dot fill NA is as the function fill NA, and in this function you need to provide the values. Okay, and you need to tell in place equal to true. Okay, and that's it. Okay, if you open this now, you will see the NaN value is replaced with the mean value, right? Hit this to one. Okay, so you can fill the NaN values using the pandas library, pandas data frame itself. Now let's see another method using the scikit-learn. Okay, using the scikit-learn you can do like this. From you need to import a function, import a class actually, that is okay, that is inside a module called impute, and inside the module we have a class called simple imputer. So let's impute uh, sorry, sklearn, that is okay. Let's run this if it is importing successfully or not. Okay, it's imported successfully. So now what we can do is we need to create an object for the class. So because this is a class, we need to create an object, simple imputer. So here you need to give some parameters. We'll see if you press Ctrl I in the brackets, you will see help. Here in the help tab we will see what are the parameters are there, what is the values we need to give. So you can see missing values, number or string or np.nan. Okay, you can give missing value. So our missing value is np.nan, right? Nan value is the missing value for us. And what value what strategy I'm going to use is mean. So you can give strategy equal to mean. Okay, so you can see here mean, median, or you can say most frequent. So most frequent we know that is a mode actually. Okay, or you can say some constant values also you can give. Okay, so after this, creating a object of simple imputer, we want to fit the object into the data, what are the columns we have, right? So you can do like data of age, or you can just say data equal to imputer dot fit transform of data. Now let's see what happens. So you can see it gives an error. What is the error? Cannot use mean strategy with non-numeric data. Could not convert string to float. So what does it mean? Anyone explain this? Anyone knows what is going wrong here?
It's categorical, I guess. So that's why. It's showing an error.
So what we can do for that?
I think we have to transform that feature, right?
Uh, so that part we'll do that next one actually. So what we can do is we can select the columns. So we can select it from here like so the problem is we are giving the whole data. In the whole data we have the columns which are a categorical one, right? So we need to apply this simple imputer on these two columns only, on this numerical columns, age and salary, right? So we want to give only these two columns, okay? Then it won't give the error. So what I'm going to do is I'm going to select uh, data dot ilog, let's say. I'm going to select this column, or a simple way you can select one by one, like age column, give the age column and fill the age column. A simple method will follow, okay? And then for same as uh, the sorry, the salary column. Now it won't give you error, right? Expected 2D array got one dimensional array, okay? So now you can see here the value is filled. So what I did actually, I just taken the selected columns. What are the columns? Age and salary, okay? And then I gave the same data of age and salary data. I gave this data to the imputer, and it's finding the nan values and filling with the mean values, and it's returning these two columns. Now on these two columns I'm overriding in the age and salary, and then you can see now the nan value is filled up, okay? That's how you can do with a simple imputer. So you need to give the selected columns that are numerical one. If you give the categorical one, it will give you this error value error, okay? So now let's see, this is step one. So we have filled the nan values. Now the step two will be converting the categorical data, like in the country column and the purchased column we have, right? We need to convert these categorical columns into a numerical one. So for this we have two methods. One is label encoder, label encoding step, and another one is one hot encoding step. So we'll see that if you have a purchased column, like let's say here we have only two categoricals, right? One is no and yes. We can fill this type of categoricals with simply 0 and 1s. We can say no is for 0, yes is for 1. What about this France, Spain, Germany? We have three type of categorical, right? If you fill with 0, 1, 2, then it will be like a numbers, right? If you have a numbers, that means 2 is greater than 1, that means Germany is greater than Spain. So that mistake we are not going to do. So we have two methods I said. Wait. Yeah, here. So we have label encoder and one hot encoder. The difference between label encoding and one hot encoding, here it is. So the label encoding only converts the labels, the categoricals, into a numerical one. Like apple will become 1, chicken will become 2, broccoli will become 3. Okay, it's better to use label encoder when you have only two type of categories. Okay, when you have more than two, that means you should go with one hot encoding. Why? Is because here, if you do only the label encoding part, what will happen? So we are just having in some numbers 1 2 3, right? So in numbers, 3 is greater than 2, we know that. 2 is greater than 1, right? So that means you are implicitly telling that broccoli is greater than chicken, chicken is greater than apple. So that we don't want to do that. So for that, what we'll do is we'll create uh, each and every categories will create a separate columns. Like for apple we'll create a column, for chicken we'll create another column, for broccoli we'll create another column. So these columns containing only 0 and 1s. Why? Is because if the apple is appears, put 1 there, other categories will be 0. Okay, if the chicken is appear, then put 1 on the chicken, other will be 0. Like if broccoli is appeared, then put broccoli for 1, others will be 0. So like that, if you create separate columns, you are not telling that chicken is greater than apple or broccoli is greater than chicken. We're just saying apple is appeared, chicken is not appeared, broccoli is not appeared, like that. Okay, so all the columns will have only 0 and 1s. This is the step of one hot encoding. So if you have only two categorical type, you can just use the label encoding part. Okay, let's see what happens. Now in purchased column we have two categories, in country column we have three categories. For purchased column we can just say label encoder we can do. In country column we need to do one hot encoding. That means for country column we need to create three separate columns. For France, for Spain, for Germany, we'll create separate columns, right? So let's do that using a pandas first, and then we'll do with uh, the scikit-learn library. Okay, I just command this to. Okay, now using the pandas library I'm going to label encode that. Okay, not one hot encoding, label encoding using pandas. Okay, what we can do is we're going to fill the value with, for let's say for no I'm going to give 0, right? For yes I'm going to give this label encoder, right? For yes, like we have shown in the example of apple, chicken, broccoli. For apple we have 1, for chicken we have 2, for broccoli we have 3, right? So like this, for no I am assigning 0, for yes I am assigning 1. Okay, this we need to replace in the column. Okay, like data dot replace, sorry, yeah, replace, to replace, uh, wait, you can press Control I. If it doesn't show you, you can press the Control I. Here you can see it is retrieving the object. So here the parameters are two parameters we have, to replace and the value. Okay, so it can be scalar, dict, list, str, regress or no. So we have dictionary here, like what we are going to replace by this no and yes will be replaced as 0 and 1, right? And the first parameter is to replace, how to find the value. Okay, to replace the values, to replace the purchased column, right? And what value we are going to fill? We are going to fill this value, no equal to 0, yes equal to 1, and we need to put in place equal to true. I will tell you in place equal true why we are doing in place equal true all the time. All right, so I will tell you that. Okay, here let's go to the variable explorer and create, open the data. Okay, it's not replaced. Wait. Okay, right. So you can just give the fill value no and yes, and you need to give in place equal true. If I take in place equal true, see what happens. Nothing changed, right? What is because if you put in place equal true there, it will update the original data frame. So this is the data frame data. If you put in place equal to true, it will update the original data. If you not give the in place equal to true, then it will return a new data. It will return a new data. If you see the new, it will be updated, but the data is not updated. You can see now. Here we have the new, right? In the new we have converted the purchase like 0 and 1s, but in the data it's not converted. Why? Is because we are not updating the original data. We are just uh, saying that replace it and return the new data frame. Okay, so that's why we use in place equal true to update the original data. In place equal to true. Now the original data will be updated. So this how you can do label encoding using the pandas replace function. Okay, so now let's see using the scikit-learn library. So in the scikit-learn we have a class actually for label encoding. So you need to import that first from sklearn dot pre-processing. In the pre-processing module we have the library, sorry, the class label encoding, label encoder, you can see here. So this is a class. Now we need to create an object for that. Lb equal to label encoder. Okay, it doesn't take any parameter, actually it doesn't has any parameters. So now after creating the object you want to fit into the data set. Okay, what column? We have the column that is purchased column, right? In the purchased column only we are going to apply this label encoder. Lb dot fit to transform into the purchased column. And that's it. if you run this, it will be the same as what we done using the pandas. So here you can see purchased column is becoming 0 and 1s, right? So this is how we can do on the label encoder. Now let's see one hot encoding. One hot encoding using pandas we'll see first, and then scikit-learn. So now in pandas we have a function called get dummies. Okay, you can call this function using pd dot get dummies. Okay, in the get dummies you need to provide the uh, let's see the parameters. You can see you need to provide the data first and the columns which you are going to uh, encode. One hot encode that the columns in the columns parameter you need to give columns equal to, we need to give us a list. So we have only one columns, that is country, right? Country. And you can use another parameter, it's called prefix actually. So prefix, I will tell you that, wait. So this get dummies return the value, not in place equal true, it will do, it will return a value, return the new data frame actually. Okay, let's see. If you open this data column, data frame, you can see we have country France column here, country Germany column, right? For country Spain column. We have three columns, new columns: country France, country Germany, country Spain. Okay, so all these columns start with the name of the column country. Okay, you can select the prefix also. We have a parameter prefix. If you give none, if you give empty value, it won't be use the country underscore. It will use only underscore. See, underscore France, underscore Germany, underscore Spain, right? This is how you can one hot encode, or you can say you can create separate columns for each and every categories using the pandas get dummies function. Okay, now we'll see for using the sklearn library. So for that, the same class here in the sklearn, not label encoder, we need to import one hot encoder in the pre-processing library, pre-processing module actually. uh, Import the one hot encoding is the class we are going to use. And we want another class also, that is we can find in the compose module, that is column transformer. We are going to use this column transformer to uh, apply the one hot encoder. Okay, so we need to create an object for column transformer. Column transformer, here you need to give two parameters, then is transformers. In the transformer you need to give a list of tuples. Okay, list of tuples. Inside the tuple we have the encode. So for this column we are going to encode using the label encoder, sorry, one hot encoder, right? And using this object. And what is the feature, what is the column we are going to apply this one hot encoder, you need to give in the list. The column index is 0. This is the first column, right? Country column, this is the first column. So here, this is how you need to give. And you need to give another parameter. If you don't give the parameter, all the other columns will be removed. I will tell you what is the parameter is. The parameter is reminder actually. uh, yeah, here reminder. So reminder default is drop actually. Why is drop means only it will transform these columns, like it will transform the first column, country column. It will encode the one hot encode the columns, other columns will be dropped. So we don't want to drop the columns, we want just pass through the columns. That means keep the columns as it is. So you need to provide a reminder equal to pass through this value. Okay, now we have given reminder as pass through. Now what we need to do is we need to fit into the data. Cte dot fit transform on the data. That's it. If you run this, you will see a column, three columns, 0, 1, 2. Okay. Actually, what it's doing, it is creating a numpy array, not the data frame. It is creating the numpy array. That's why we don't have any names for the columns. We only having 0, 1, 2, 3. Okay. This is how you can one hot encode using the scikit-learn. Okay, now we'll see the third step is, after the one hot encoding, we'll split the dataset into what, training and testing, right? So the splitting part we'll going to do here. So the splitting can be done using the sklearn library. From sklearn library, inside we have a module called model selection. Inside this module we have a function called train test split. This function will help you to split the dataset into training and testing. Okay, now this function will return four values: xtrain, xtest. This is a two part for x and y. So before splitting the dataset, we need to find what is the x and y variables. X variables is the an independent variable, y is a dependent variable. That means x is the features we are going to use for predicting, y is the variable which we are going to predict. Okay, so in the data, for example, let's say we are going to predict whether the customer will buy this product or not, purchased or not. Okay, this is what we are going to predict. Okay, this is the outcome. So this will be a y variable. That means this is a dependent variable. Now these features 1 to 4, these are all independent variables, x variables. That means using these features only we are going to predict the outcome, the y variable. So that's why we need to do, like, we need to separate the columns. X equal to, right? So I will just run. Before this, uh, I will run this one, and here we have the data frame now. Okay, not the array, we have this data frame. In this data frame only we are going to separate the column x and y. Okay, so what we can do is, for x variable, so before I will do only for y variable. In y variable we are going to select the column purchased column, right? Only the purchased column. So you can select using this, like, put square brackets and give the name purchased. This is the column we are going to use for uh, predicting y. This is an independent variable, sorry, dependent variable. Now other than this purchased column, that are independent variables. Okay, so what we can do is, so we can drop this column. right? If you drop this column, you will left with all other columns: age, salary, France, Germany, Spring. That columns we want for independent variable, x variables, right? So we can do like this: x equal to data dot drop the purchased column. That's why I just put the x in the second after the y, because first we are taking the purchased column and store in the y variable. After that we can remove the purchased column. Okay, that's it. So if you run this, you may find uh, not for, okay, we need to give the axis actually. If you want to remove a column, the axis should be 1. Okay, we have a parameter called axis. You need to give 1 for column, 0 for row. Okay, now you may see two new variables, x and y. In the x we have the columns uh, without the purchased column. Okay, and here in the y you will see only the purchased column. Now these are all pandas data frame and series. Now actually we don't want the series or data frame, we want only the data as a numpy array. Okay, to convert this data frame into numpy array, just put dot values. It will create a uh, numpy array. Okay, n dimensional array. Now the same as for this one. Okay, x and y variables both. Now it will be the array. You can see array of float 64, array of into 64. Now this is an n dimensional array. Okay, now this array we are going to give for the train test split. Now we have the x and y variables, right? We are going to split into two parts: testing and training for both variables x and y. That's why we have x train x test and y train y test. So we need to call this function train test split. Here we need to pass the variable x and y, and we have two more parameters, that is test size. What is the size of test data? That means, for example, if I give 0 point or just 0.25, that means 25% of the data will go for test and other 75% will be for training. You see, if you have 100 datas, 100 observations, 25 for test, 75 is for training. Okay, and then we have another parameter, that is a random state. So random state is nothing but usually in this train test split function, what it will do, it will shuffle the data. Okay, it will not take from beginning to end line by line. It will shuffle the data and pick randomly. Okay, that's why if you put the random state, if you set the random state, it will take the random state. Okay, uh, I will just run without the random state, and then you will understand what is happening here. So now I will run this program. Now you can see four more variables there in the variable explorer: x test, uh, x train. Okay, and then the y test, y train. So if you see, 7 observation is for training, 3 observation is for testing. So here just observe the values like 38, 61,000. Okay, now if I run one more time, see what happens. The same x train, see, 35, 58,000. It's just changing the value because it's just randomly picking the value. If I put the random state to set as a value, it will use the same state, random state. For that, for example, I'm picking 10 here. Okay, if I run this now, you will see Now here 38.77. Okay, I remember that. Now if I run one more time, it will be the same one. It will not change. Okay, it will not change the values. That's what we use the random state. Okay, so now we have splitted the dataset into testing and training. Now the last step will be scaling our data. We'll see that what is scaling means. Okay, scaling means, let's say we have more than one features. All the features needs to be on the same scale. If you have age and salary, these two are the different scale. That means age can come in like 1 to what we can come 100, let's say. Okay, salary it can come lakhs, it will go. Okay, so the scale for age and this salary, these two columns are not same, right? So what happens if it is a different scale? So our machine learning algorithm will understand like this column is more important, so it will give a more important for that column uh, if that column has a different scale, right? Like for example salary column, if you multiply the salary with some values, it will be the large value, right? So it will give the our machine learning model will give importance for the salary column. So we are not going to do that. We are going to give the same scale for all the data, all the features that we have. Okay, so that's why we use the standard scalar method to scale the features. So here you can see in the picture, before scaling x1, x2, x3, we have different scales, right? So after the standard scalar, all the features will be on the same scale. So what inside the standard scalar it is doing, it's just doing this equation, xi minus mean of x divided by the standard deviation. Okay, and then it will be become the normal distribution. Okay, okay, to do the standard scalar, we need to use a scalan library. In the scalan library, we have the module, the pre-processing. We know that we have already used that, and inside that we want to import the standard scalar. Okay, standard scalar. Now we need to create, this is a class actually. You can see all the classes start with the capital letter, uppercase letter. So here one hot encoder, capital O, label encoder, capital L, simple imputer, capital S. These are the classes actually. To identify the class has the first letter should be uppercase. Okay. Now let's create an object for the standard scalar. Okay. We don't have to give any parameters, just simply standard scalar and brackets. So now we are created the object. What we need to do is we need to fit and transform on the uh, data. So why, what function we are using? If you observe fit transform, what is the function? It means what the function is doing, right? So if you see the fit, we have three functions actually: fit and transform and fit transform. These three functions we have. So what these functions will do is, fit function will only calculate the for example, if you are using the standard scalar, that means it will calculate only the mean and the standard deviation for the data for each and every columns, right? So fit function will do that. So only it will calculate the mean and standard deviation. And transform function, what it will do, transform function will apply this equation to all the data. Okay, for example, we are calculated the mean and standard deviation, it will use the mean and standard deviation and apply for all the data. That what the transform function will do. Now we have another function, fit transform. Both the operation will do, we can do with the one function. Okay, in one shot it will do, it will fit and transform, both will do for fit transform function. Okay, now in the standard scalar, what I'm going to do is I'm going to fit onto the training data, x train. equal to. So on extrain also we don't want to fit for all the datas, all the features. See here, if you open the extrain here, so you can see only the age and salary columns only has the different scale. Okay, but in the standard scaler actually, uh, what scale it will use is, it can be from -1 to +1, or -2 to +2, or -3 to +3. It can be anything. Okay, the range will change actually. So here only the age and salary columns has the different scales. So these are the same scale, ones and zeros, so we don't want to use that. We don't want to standard scale at that. So that is already has the scale of 0 and 1. So we want to scale only these two columns, right? So what we can do is we can select the two columns only. So all the rows we want, just put colon, and after comma we want to select the columns 0, and you need to put 2 actually, not 1. So upper bound is excluded, so 0 colon 2 we need to do. So that means you are selecting two columns, first and second. Okay, and now we are going to fit and transform on this data. What data? This same data. Okay, so now we have done with x train. Now for x test, let's see, x test of colon comma 0 colon 2 equal to st dot transform. So here you may have a doubt why I'm doing uh, transform only for test. Anyone has an idea why I'm doing like this? So I'm fit and transform, I'm doing fit and transform in the x train, but I'm doing only transform for test. Anyone? So after the transformation you can see that it will be on same scale, like, okay. So I will tell you why I'm doing only transform for test. It's because the fit transform, what it will do, it will first fit on the data, and transform will apply the equation on the data, right? So we are fitting on the training data. That means our model, our machine learning model, we are going to build, that model will only build using the training data, right? So in the training data we may have a scale, right? For example, -1 to +1, let's say. Okay, this scale must have the same scale for test data also. If you have a different scale in test data, that means our model will not predict correctly on the test data. So the both xtrain and xtest have the same scale, but we need to use the scale of training data for the testing data also. So that's why I'm in the first, for training data I'm fitting and transforming. I'm fitting on the training data just for, I'm just calculating the mean of training data and standard deviation of the training data, and apply the equation on the training data. And after that, on the test data I'm just applying the equation. Okay, I'm not uh, fitting again. If you fit again, it will calculate a mean and standard deviation for the test data, so we don't want to do that. We want the same mean and standard deviation which we used for training data. Okay, so here if you see on the variable explorer, I'm opening the xtrain. If you see, these two columns has the range of, for example, 1.5 to -1.5. Okay, if you open the test also, it will be the same scale. Okay, here 1.8, 1.9 it has, so it will be the same scale, right? That's why we are uh, doing like this. For training data you need to do fit transform, for testing data you need to do only transform. Okay, and that's what the pre-processing steps are. Now we are prepared our data to create machine learning models. Okay, now our data is prepared now. Okay, so this is what we'll cover today. We'll end up this session from this. Any doubts you have, you can ask.
Can you share that file with us?
What?
Can you please share this code?
No, actually, no, I don't share this file. So this on the video. You can watch it in the video.
Okay. Can you please, come down a bit?
Yeah.
Yeah, fine. Thanks. I just wanted to say.
Okay. So any other
So,
doubts you have?
so you use um this one. Sorry. Uh, the tool you're using is
Spider
the
ID.
yeah, Spider ID. So,
So you can do the same in any environment also. If your the library are installed, then is okay. Then you can start type coding the same one. So actually all the environment doesn't has this scikit-learn and these libraries pandas, numpy, matplotlib. But if you install the anaconda I said before, so
yeah,
that anaconda environment has the libraries pre-built. Okay, so you can just import it and use it. That's
I
why
just
I'm
wanted to
using the.
know which one might be the better one. Comparing Jupyter Notebook and Spider.
So spider you can use when you are just coding, but a Jupyter notebook we can use when you are going to present the what you done. Okay,
Okay.
so that Jupyter notebook allows us to create some text on the file also. Like we are using .py, right? .py in Spider, but in the Jupyter notebook it will be a different one. You
Mm,
can write codes or you can write some notes. So if you want to present your what you've done, you can use the notebook, Jupyter notebook.
okay.
Okay,
Yeah, there we have the
this.
ability to run it, cell wise, and
Yeah,
do we,
yeah,
can we do that here? Select a block and run it. Is there
yeah.
something?
Select these two lines and you have this right. If I'm selecting these three lines, let's say, and I can run these selected lines, you can see here. Now
Okay,
these three lines only executed.
understood. Yep, thanks.
Okay.
Hello, Irfan.
Yes.
What if the country column is missing?
What is the country column?
What if the country cell is missing, like salary and wage column?
No, I don't get.
First of all, the salary and age column has none, no values.
Nan values. Okay,
Yes.
okay.
What if the country column has it?
If the country column has it, what you need to do is one way is you first you need to convert into a categorical to numerical one, and after converting that you can see the nan values, right? Now it will become a numerical one, or you can use a method like mode, frequent values. Like here, let's say France. If that France occurring like one occurring more than zero, then you can fill the nan values with one.
Okay.
Okay, using the uh, mode.
Mode, mode type.
Yeah,
Okay.
so you can't use mean or median in this columns, like in the categorical
Okay.
one. It's because you can see like it is the categorical one, 0 and 1 it has. So you
Okay.
can count the occurrences, how many times
Okay.
the 1 is occurred, how many times the 0 is occurred. So
Okay.
you can fill the nan value, uh,
Okay.
yeah, the most frequent value, right?
Yeah, okay, thank you. I can understand.
Okay.
Okay, thank you.
Uh, Hi, can you scroll down a little bit? Uh, There in the line 25,
25, this one.
yeah, you are given reminder, right?
Reminder equal to pass through, yeah.
Yeah. Can you please explain that around?
Okay. So if you see the parameter of reminder, defaultly that is wait. It will show you, wait. Defaultly that is a drop actually. So if you have the reminder as drop, what it will do, it will only encode the selected columns. That is, we are given 0 with a feature of 0, the first column. It will encode the first column, other columns will be dropped. Okay, that's the default value of reminder. If you put a reminder as pass through, then it won't drop the columns. Let's say I'm just removing this column. After that you can see what is happening here. Now we will just until this. So if you open the data, you will see only three columns: country, age, salary. Wait. Notice time. Okay, yeah. So you can see only these three columns. These three columns are nothing but country, France, Spain, Germany. Okay, other columns will be dropped. Other than the country column, other columns will be dropped. So if you don't want to drop the columns, you want to set reminder as pass through. Okay, now if I put reminder equal to pass through, need to give outside of this brackets. Now now if you see the data, you will see all other columns also. Okay,
Okay, thank you.
hope you got it. Any other doubts?
So you were using Skyline and the usual one, Skyline
Yes.
library and the usual one. So any particular reason Skyline?
sklearn is the library, the scikit-learn library is all the operations of machine learning, like for example cleaning the data or creating a model. If you see, if you put sklearn dot, for example, I'm just importing sklearn. In this sklearn library we have for all the, for classification, let's say for regression, for clustering algorithms, all the algorithms is inside the sklearn. So you can see some modules is there, right? In these modules we have the classes of the models. For example, let's say neighbors. So in that neighbors we having a k neighbors regressor and k
Yeah,
neighbors classifier. This is the model we will build for.
pre-built models are there.
Yeah. Pre-build models are there in sklearn. That's why we are using the scikit-learn library. It's scikit-learn, we can say scikit-learn library is for machine learning, and we have TensorFlow and Keras
Mm-hmm.
and PyTorch. These three are for deep learning.
Okay. Okay.
Okay, any other doubts? So if you are doing, for example, linear regression, you don't have to start from the scratch.
Yeah.
So the scikit-learn provides the class for the linear regression. You can just use the class and create the object, fit into the data. That's it.
But
So
when you start learning, data science and machine learning, so how
yeah,
good it's that, you directly use it or you go from scratch?
yeah. If you want to better understand, you can go from scratch, right? If you are just starting from the beginning, you can use some libraries, right?
Yeah.
If you want to learn in depth, you can go with the scratch. So you will start typing coding from the beginning to end. You will type the program, right? Otherwise, if you are the beginner, you can use the pre-built libraries for creating the models, right?
Hello, Irfan.
Yes.
I was recently asked of a question on one hot encoding. Uh,
Mm.
the interviewer asked me to encode pin code column.
What pin code
Interviewer,
column?
yeah, I usually tend to drop them, but he was fixated that uh, it is relevant to the model. So what will we do?
Wait, pin code, like for example, pin code or passenger names are unique ones actually. Okay, all the values are unique. If that has like uh, if you are saying pin code, no, pin code we can't encode actually. So actually, because pin code is a unique one, right? Every pin code has the different values. So it has uh, more values on pin codes, right? If you have 3 or 2 or more than 3, more than 2, we can use the one hot encoder. If you have 2, you can use label encoder, right? So if that is a unique one, then why we want to encode? Let's say for example passenger name. So passenger id or passenger name, that are unique ones, right? So for the unique type of data, we don't encode. We just drop the columns, right? Or if you're saying pin code are in numerical ones, right? Or you want to drop, you can use it pin codes.
But if I use directly those pin code, it will cause the same issue as a label encoder does. Like the rank of features will be set to model, and model
Yeah.
may
Hmm.
predict wrong.
Or you can drop, I think
Okay.
it's better to drop that. Or
இப்போ என்ன 5 minutes
what's that?
மேல ஆயிடுச்சு இல்ல
Oh,
சும்மா
okay.
ఏంచి
So
కూడా
I think what's that?
ఆఫీస్ పోను ரொம்ப நேரமா கூப்பிட்டு இருக்கமா 6 o'clock இப்ப 8:30 ஆகுது ஒரு வாட்டி ஏஞ்சி உட்காந்துறேன் ரெஃப்ரெஷ் ஆயிடும்
Okay, any other doubts you have?
That's all for now.
Okay.
Thank
Or else I think for the pin code, maybe if you scale that, what will happen? Maybe.
If you scale that, using min-max scaler,
Yeah, yeah.
it will be 0 to 1s.
Hmm. Okay, okay. That may not work. Huh?
Yeah, I think it will work.
Okay, let's see that. I will see that. Okay, I will tell you tomorrow.
Sure, sure. Thank you.
Okay, okay, okay. Let's end this session.
Thanks, Irfan.
So today is 15th day. We have started machine learning. So we are bigdatahandson.com. Our website bigdatahandson.com. You can visit our website. All the previous videos until 0 to 1 to 14, day 1 to day 14, are uploaded in the YouTube channel bigdatahandson.com. So you can watch the videos. This video will be uploaded as soon as possible. Okay, so here you can see it's the day 14. You can see the numpy matplotlib cpon pandas library. I have taken the class day before yesterday. Okay, you can watch other videos also. If you subscribe to our channel, you will get all the updates. Okay, let's see tomorrow. From tomorrow, actually today we are just covered two steps. One is getting the data and cleaning the data and manipulating the data, preparing the data for the model. But now we are not created any models, right? So from today we'll start creating a model. Okay, let's see tomorrow.
Thank you so